This is Mustafa Bosch, and in the previous video we talked about the types of data, and we also talked about the type of distribution. We said we have continuous data, we have ordinal data, and we have nominal data, and we discussed the difference between them. And we also said that we talked about the distribution. We have normal distribution, we have left skewed distribution, and right skewed distribution. So this was very important in order to understand the difference between the parametric and non-parametric statistics. So when we talk about parametric statistics, we need the population to be homogeneous. Like we need to have a homogeneous population. That means the characteristics of the population are similar. Okay? When the population is homogeneous, this leads that there is a normal distribution here. Okay? There must be a normal distribution. Okay, this is one of the assumptions that you use in order to use parametric statistics. There should be a normal distribution, and we talked about the type of distribution here. This is the normal distribution, and this is the one we use with parametric statistics. But for non-parametric statistics, the population is heterogeneous. That means the characteristics of the population differs a lot. There is a lot of heterogeneity within the population. So here, like the good thing about non-parametric statistics is that it does not strict, we do not say that we have to use this type of distribution. Okay, it does not require that we have to use normal distribution or skewed or any. It can deal with any of these. It can deal with normal distribution. It can deal with skewed data, and also the data with outliers. This is very important here. For parametric statistics, it cannot deal with outliers. And outliers are values that are either too high, okay, or too low, okay, in the data set we have. Okay, so parametric statistics, we have normal distribution. For non-parametric statistics, we can use any type. If the data is any type, it can deal with it. Okay, the parametric statistics, it uses continuous data, but for non-parametric statistics, it uses ordinal data. As we said, continuous data, we can use even the fractions. We say 10.1, 8.0, like 15.5, like we use percentage, 50%, 60%. This is continuous data. But ordinal or nominal data, we have to use like either in order, like 1, 2, 3, 4, 5, or we use in nominal data, like we use like age, like gender. Gender, we can say like male or female, country, or something like that. Okay, we can use it with non-parametric statistics. So when these like parametric statistics are very powerful, and it gives us very strong like results when the assumptions is true. If we have a normal distribution and continuous data, the parametric statistic is the most powerful. But if these assumptions are not met, then we have to rely on the non-parametric statistics. If the data is not normal and it's not continuous, okay, then it is more reliable, and the non-parametric will give us better results. For parametric statistics, we usually have a large sample size, and for non-parametric statistics, we usually have a small sample size. And for parametric statistics, we usually focus on means. Like when we talk about means, variance, confidence intervals, like means is like the average values, yeah? But for variances, I'm not sure about that, okay? So for like non-parametric, it focuses on ranks or frequencies. Like when we say the frequency, that means how many times a value have been repeated here. When you talk about the median, it is the value in the middle, okay? So like there is different type of statistics for each. Like for parametric statistics, we use the t-test, ANOVA, Pearson's correlation, linear regression. For non-parametric statistics, we use like mean, Mann-Whitney, Willickson, Saint-Rank test, Friedman test, Kruskal-Wallis test, and chi-square test. So this is the main difference. So For parametric, we have normal distribution and continuous data.